I think you heard in the when you learn physics in Thanh-Sach, right? Okay. Here in real line, real come and then focal length is usually in millimeter unit. How long is it? But in vertical camera, it measures in this way. This way. So you can see that is the effect of you have a short focal length, long focal length. The object becomes smaller, okay, sure, from here to here. Or larger depending on you get a focal length. And then if you make the hole, it becomes bigger, and then the image becomes blurred. Okay. Why? Because one visual image detail receive the color from many points, so that we blur. So some video is just the mathematical model, not real. In real camera, you have to use the lens. That is the physical lens. So I think then the real camera is more expensive, right? Compared to other device in the camera. So here, that is the idea of physical lens. And I think the way to for working your plan, I think you learn in the high school, right? Okay, the idea. You can see. You have mainly from the sun. Okay, you have many rays from the one point in the 3D model, and then it hit to many lines, but it's converged to this one point in the image plane. We call focus. When lost focus in our image plane here is not on the point here, but it goes to the left side and right side of a little bit. We call lost focus. Okay, that is the idea of some concept related to imaging. Now we go to the mathematical model. How to model the imaging process. Okay, we talk about imaging process from here, right? Imaging process thì mình còn quá trình của nó, hay là sự hay là gọi Actually, now we saw in mathematics, so that's why you can see, not surprise, quite simple. Here the model is just multiplied between the point in 3D with the matrix we call the camera matrix. So in order to determine the camera, or we call calibration, you have to determine the parameters for in matrix. That's all. Quite simple, right? In computer graphics, you play game and you whatever, but actually in underlying you just multiply between the point and also matrix. That's all. And here the physical camera, and then when you use the income division, we have to model that. The model is just here. And how to make the image, just multiply. That's all. And it's simple. The question here is how to determine. You have to step by step. I want to introduce you about the homogeneous first, right? I think that I only introduce in the chapter 1 or chapter 2 related to the geometry transform. Okay. So usually you can see in 2D one point here is Fy, here is Fy. So in 2D, nobody don't care about the homogeneous, the representation of point and vector the same. So when we input to the computer Fy, the computer don't know that is vector or point. Okay. And But 2D, but homo, a variant for homogeneous. And then you introduce one that is S, Y, and 1. And for vector you S, Y, and 0. So you remember here. Now representation is quite different. So when you input letter to the computer know that representation here is vector or what. Okay. And for 3D, you also have here F, Y, Z. And here the same F, Y, Z. Right? And for 3D homo, you have F, Y, Z, and W now here is Y. Here is F, Y, Z, and 0. Okay, now Y. You can see quite different you have for point and vector. But after you transform, right, then for more general. Okay, you have F, Y, and W in 3D homo. And you convert into the 2D homo by F divided by W, Y, W, Y. And similar here. So you convert into the what we want here. Okay, see the ball. What is the concept of homogeneous? We introduce one dimension. Okay, one dimension. And usually for original point and vector, that is 1 and 0. But usually for after some transformation, especially for projective transformation during here, and then the value is not 1 anymore, and then it become 2 by or 3 by divided by the last one become 1. Okay, now you get the 3 or 2D coordinate. Yeah, now you remember the way to convert from homo to 3D or homo to 2D. Okay, anyway. So why we have to introduce first? Usually for computer, for look like computer office, you can see when you input a data and then computer is like that, and computer know that is point better. So in one advantage. Another advantage really importantly, while we are homo, we call that you have to unite all of transformation become matrix and better. Multiplication, all kind of transformation. Transform. All transformation can be modeled by matrix value. That is model. If you keep all the original 2D or original 3D rotation by multiply, translation by adding, okay, and a lot by comparison of multiply and add. But now you can unify all of them into the matrix inverter. So that's why easy. Why easy? Because for hardware they just accelerate matrix multiply with matrix. So that's why you can see right now you have some before you had a computer or you had a GPU card, and then before that they had some, for example Intel, they had some set of instructions to accelerate the computation matrix inverter only. But right now, okay, GPU, right? Accelerate. So you can see that is very hard. So you can see right now, in 3D, original 3D, you are actually only at Y, big S, Y, Z, here in 3D. And you multiply with matrix, and then now we only 3 by 4, and then it become here X, Y, Z, okay. And that matrix here transformation from the camera from all 3D into the image. But in order, because image is only 2D, so that's why you have to divide Z here, S by Z, Y by Z. Okay, that is the idea. So the camera, you can see that you have to mesh the that become calibration. We have to determine value based on data. So that's why it means that you have to determine on the value here. That is 12. Actually only 11. Right? So that is the model. I introduced the model. Important. When talking about camera in Ipcv, it means that you have to know value of it. Okay, the question here is the idea. Usually, here you have a 3D object. Look like this. You play the camera, for example here, represent for camera. For example here in 3D, here the camera. Okay? And then actually the camera right now here is by also the we had a one attached to one frame X, Y, Z also. Can you see it? X, Y. So you can see here in 3D, and we play here the camera here is Z, and right now you can see you have image plane in front of. Now here from here to here we call the focal plane, different from image plane. Now focal plane is in this image between that is focal plane and photo to one. So in order to make imaging, given the picture the 3D for example S, and given you the camera parameter, means that the camera value before, you have to determine for me, okay, the version which is the version in the image, means that the coordinate of S here. Okay. If you determine coordinate of S, means that you know where is it in the picture. In picture, right? It is a lot of mathematical problems. So at the end now you can see you have here the camera, and then you have a point, and then you make a drawing, and then in the set picture here you determine the position here. That is the idea. Okay, okay, that is how to make the picture. And the question is how it related to the F. So into detail, right? Very simple. Can you tell me if I give you the theory image plane that is perpendicular to the Z, and give you the location of X1 without the coordinate of S. S without the S, Y, Z, because S is 3D. Right? That is not the coordinate, but that is the point, represent point. Remember, here is both, here is not both. So here is Y axis, here is Z axis, here is Z. Can you determine about here? What is the form? You had it, right? If not, you had it, determine from here. You have to use in the secondary school knowledge. You can show what is the name of that theorem. How related to you have to use similar triangle, even though we call tam giác đồng dạng, where you can solve that. Okay. Here actually here defined by Z, divided by Z, right? But if you can see it coming to more general. Okay, because it's quite simple. It's come to my example here. What the definite F? Not what. Okay? And then you have the formula here. Right? similar triangle, then you can solve that one. Is it okay? So if in that, what I mean, if now, if you give me about the position of x, y, z, and then I know the coordinate in image plane, that is right. Okay. And that is just for one point. But you have to compute a lot of points, otherwise you have to do the model in metric inverter. So here metric inverter là sẽ for this case, I multiply this with this equal to this, right? And then can you tell me why? And then you have relation from here to there, right? Can you tell me why B1 equal to 1, B2 equal to 0, and only 1 here 0? Do you know what? Can you tell me why? Why 0 and 1 in the matrix P?
No rotation and no translation.
You have to solve for symbolic multiply between matrix inverter, right? Symbolic multiplication only. And then you identify to what? To that rule, right? And then you get that matrix. Okay? Can you solve that? Is it clear for you? Clear for you? Do you know why? Why you get the 0 and 1 here? Based on low nature. I highlight you together. First, multiply this vector to the matrix by symbolic way, by PQ, okay? And then you deal that identical to that row. Because that the first below that is the constraint between the input and output, right? Between 3 and 2D, right? And then you have to identify and then you get the result here. Is it clear? Do you know how to? Just tell me yes or no. Is it clear or not? Clear or not? That's one, right? So okay, usually in sorry. I want to introduce one more. In computer vision, because computer is very long and very heavy topics in mathematics, right? Otherwise, and very beautiful book. And in that field, I recommend you to read book. First book here by Bob, but very well-known person we call Richard Hockley and Unreal System. You just search his name and then you can see very well-known. And the topic today here we talk about chapter 6. Right? So read chapter 6 enough. Very clear, and very heavy in mathematics. So that's why I recommend you to shorthand to read it compared to slide, right? Slide not enough and easy to listen. And another book we also and from Richard's the Silicity and also very well-known version also. And the third book is model and computer model by David Fossey. Okay, I don't have the version here, right? On that book, I will order the library in factory to buy and then you can borrow from the factory. But I think you have still to find the book. Yeah. So actually, if you don't have, at least you have at least this book. This book. But here, usually they have to divide into sections. But we call I right now, zero I, that is 0, right? Remember here, bold represent for matrix, also bold represent for vector, right? You can see that you just combine two matrices, the one matrix vector, one is secret denotational. For that. So if you have formula in different one, then you have here F formula. The new formula in real life, the formula you can see the length and it measure in millimeter. But after calculate it and then measured by visual, number of visual. Okay, you can see here. What is it? Now to make more general, first you just know about symbol of camera. Now we combine two. We have one word point, a word coordinate system, or we call word frame. Here actually 3D, right? But I draw them here. The order done by 3D, but actually really 3D. You also have the camera. Going here. You also have the image going here. You have 3 frames. Actually, in computer graphics, you have 4, a lot of systems. Okay, but right now they simple. You have word. What do you mean word? What the camera, you know only the camera system here, right? You capture. But word, what do I mean word? Word means the surrounding environment of camera. Okay? If I capture, here put the camera and then camera over the world system, right? And camera also in world system. Camera also in world. Okay? Mean that the content around the camera. Okay? The camera capture. So that is world. Image camera you know only. And also the camera has an image plane. So image plane inside that is the 2D picture. Okay? That is it. So you can see that is. In that image plane, image camera and image plane, what do I mean? You can see. Go back to the picture here, let me clear for you. That is geometry. Yeah, okay. That. The camera always has the image plane. The model of image plane is in front of the camera, not in the physical, opposite side, right? So that because of mathematics, camera and the mathematics, so that's why you move the image plane in front of the camera. Okay, so you can see here image plane is one coordinate system, here another coordinate system, and here also work, right? Now you find relationship between them. And next, you can see usually the image plane is the, furthermore here is the z-axis. Z-axis. You can see back to the picture again. And see it. The z-axis here is the z-axis we call the principal axis, and it intersects with the image plane at the one point we call the central projection. Okay, and you can see that is the central projection here. That is the principal point. Now here might be in the middle of image. So let's see about camera. Let's remember you have 1, 2, 3. Here physical. Now here mathematics. Now for OpenGL, mean that the computer vision. The camera is your left hand side. What do I mean? X, Y, and Z axis. Where? What I mean? When it captures, if there is a camera, the Z is go right, X is go right, Y go up or maybe go down. Now this will go up, and Z is toward the positive toward the scene you want to capture. That is method model for computer vision, for example in the book of Hartley and Disney. Okay. This also. So in computer vision, they want to, they try, remember very important, the Z, point Z is toward the scene you want to capture. Left hand side. But for OpenGL, okay, you hand side. X, Y, and Z. So if you learn computer vision, computer graphics, you learn OpenGL, you can see what I mean. S, Y always walk, and Z walk positive go to your cell, and then on the negative side, the scene you want to capture. Fine. You can see that is on of the open gel library support right-handed shot, right-handed shoot. Còn right and left. Immerse here go to your eye without the camera. Mean that the area you want to capture is on negative side of object, but for computer vision on positive side of object. That is why you can see why that is important. Because in during transformation you have rotation. That's what about rotation. Rotationally, you want to rotate something must be surrounding some axis, right? So rotation is negative or positive depend on the axis. Do you know why? Depend on axis. So that's why this affect the rotation. Sorry, okay, again, I want to remember in computer vision, okay, you had a world system, mean that you had a frame, not X, Y, Z also. You had a camera, okay, camera. And you also have what? You also have image plane. The image plane is inside the camera. Inside. So you have three. Now you want to, the goal is you want to determine the point S on image plane given what? Given the 3D coordinate and also camera. Right? Okay, that is the goal. Mean that you want to determine the coordinate. Very short. But right now you can see. The camera now divided into the because the image plane usually is the center at W12 without what I mean. The image plane is the center. Right? So what you have to have the camera in here to go. So you can see now you have to determine the point in world. The point in world. That is have already S and what are the zero without the homogeneous system. Without zero also there but in the original system, right? Just add one more dimension now. When you have zero and add one more like and actually you have the ray here where I see in the image plane. That is the goal. Where I see, right? So you can see how to determine image. For the ball you have a point, there are some points in world, and then you know, and then you also know the camera is playing world, where and where is it? That is the that is 3D, right? Where you go. And then you have to think into the two transformation. Okay, maybe I give you a normal example, and then you can see it's easier to explain. F, that is Y. Remember for world. World without okay the common, right? The camera is also world. Okay. So here is also I remember here I draw here for 2D and the principle is the same as 3D. Okay. So right now for here I give you about 45 degree, okay? When 45 degree. and model 1, model 2. So here 1, here 2. Quadruple here rotation. YCSC. Okay, I will draw in 2D, okay, for this. I see that here in work, I give you. Because the camera also in the work, so that's why here in 2D, here I represent for camera. In 2D, right? And then first, in order to also have image plan, right? So maybe image plan is another system, but right now we focus on D2. If I play the camera in here and the position 2, minus 2 and 2 in work. So for the point right now, for the point, or maybe another point. Let's see. This point and this point. We control A. So you can see for B, what is the point A in work? What is the point of A in work? Answer me. Two, 0. Because the vector is always first, so why I use the position to have here in B word is equal to 2. First, sure, our goal is farther than that. We have a point in work. We play the camera in work. You have to determine the point in image plane, right? Okay. But right now we have to shorten it 2 steps because the principle is same. What is the point in camera first? Alright? If you know, then you can also determine the similar way in camera in the image plane. Is it okay? So right now in work, yeah. So can we both A in C equal to how? And B in C equal to how? What is it? What happens if you fail with this third case question in final exam? In final exam, we receive similar question. Can we help it? The way SOV is similar to for 3D, right? Okay. And similarly from camera into image plane, the same. Okay. You just show one very simple step by 2D. Okay, so we help. It's true, okay? In mathematics, you know how to. Maybe you know, you learn it, you learn in linear algebra, okay? Change it, you know, but okay, now I summarize for you. In order to know where C in SE, I have to do 2. First, I have to translate the whole OC, okay? Translate OC to distance. When if it after that, it has a system logic, right? After I translate the whole SOC, T we not translate. That's right. O C S C Y C 2 O W Y W X. Do you know what I mean? After translation, okay, where is it? Right? After translation, that on the point A, B also translation. Okay? So that's why. Now that. After that, you have to do what? That. How to, here after translation, right? Translation, how to do? You rotate. When 45 degrees off. Okay? minus 45. Now minus 45. We got 45 degree must be on this side. Do you know what is the positive way? Counterclockwise and clockwise. What is right now? What is positive? What is negative? The positive and negative. Okay. So that's why you can see net you rotate. Rotate what? Rotate the result, right? Counter here we call the clockwise. First and second. Okay? You know what I mean? You translate from here, and then you rotate it to align S with S, Y with Y. That is it. So we combine to here translation first. Around vector from here vector D. Okay? Or we call around it, okay? Around T with D. And then remember, look at the ball. And then 31st and then rotation. Rotation around Z axis with 45 minus 45 degree. Minus 45. Without the clockwise. Why? And then put a right on the left side. Do you know why? Because after that I want to transform point P and then I multiply point P. I multiply point P on the right side, so that's why point P would translate and then rotate. Okay, I define with M equal to by S. And you can. Okay. So that's why in order to transform A, so AC equal to M multiplied with AW. And BC equal to M multiplied with. Even that you have to determine here.
I'm sorry, a little bit example on the board. The example concerning that we want to transform point one what actually can connect.
Yeah, but I you have to solve that up and then I understand. I explain what.
To do that, we need to transform the work connect the center of the work connect to the cam connect.
Very simple for don't think about that first and here. In order to determine A, so you also follow the first translate A by this. When you translate the camera, and then you translate A also like that. After that, you align. So that's why after two here, then after two steps here, and then the camera OSY equal to OCSC. Okay. The idea here you have to transform C into word, and then on of the point word also transform like it, and then get that. Now you can see. Tell me about very simple. What's OW? So O00. Can tell me OC equal how many? You can do that method. Can see what is the O in C. This point, the same point, what in connect the camera? What is it? You know? Can you see that?
0 minus 2 times 2.
Only in word that is 0, 0. So what? But it in the related to the camera S1, and then it is 0 that is S and
minus 2
minus of what?
square root 2
2 that is square root of 2. Right? Okay.
hai chữ chung của tương lai
So now let's see about the matrix, translation matrix. Okay, back to the. I opened the sheet. You remember in part 1, you had the transformation in geometry, right? Okay, you had a matrix in part 1. So matrix, you reply for me the D equal how many here? T of D equal to 1, 1, 1. Here, what is here? The vector come go to original. Vector here is x equal to 2, y equal to really? X equal to 2. Y vector is D. Vector here is this vector is x equal to 2 and y equal to minus 2. So you can reply here is 2 minus 2. And let's see about Z minus 45 degree equal how many? 45 degree minus 45 degree here is the same as what? The sine of minus is right, and with multiplied with minus that equal to right. And the order is 0, 0, 0, 0, 1. What will be that one? So that is polar left, right? So what can you tell me about the result here? And what is going here? You take dot between this and draw and column and then get it. Here you select only square root. Here, you select only the middle. Here, what is here? Remember here, minus 2. Here, 0, and here, 2 multiplied square. 2, that is square root of 2. Here, subtract for square root of 2, right? That is 0. It's right. Okay, 0. And next, you select only the first column. You select in the middle, so that's why here dot not to draw, so that is right. And here is what? Two minus 2 square root. Here is minus 2 square root is 2, right? And so the last one will be 0, 0, 1. Okay. So you can see after matrix here, you can see here is rotation matrix. Sorry. Here is rotation matrix. And here vector T equal to, you transform vector D. Here vector D, you transform it by rotation matrix. Here equal to what? or multiple with D, right? So you can see here R multiple D. So here is or. Not the rotation matrix. Other. So okay, right now, okay. So right now you can see if I transform the OC OW của only 0, 0, 1. Here is OW, right? Remember here all of this minus 45, and here is all z minus 45 multiplied with d, and d thì nó có equal to 1, 2. Okay. So you can see what is here. You multiply matrix here with vector here. So 0, 0, 0 not equal to 0. Right? You take dot representative matrix with column and then you get 0 because 0 and not is 0. And here is what is it? 0, 0 and not here is and not here is 1. Right? So here is must be O but in after rotation is. That's it here. What different?
You just miscalculate the diagonal of the triangle.
Which diagonal?
It's right.
And here is?
It's just the diagonal.
Okay. Because here is square 2, and then the red one must be minus of what? 2, right? It is because that is the diagonal of the square of side of 2, right? That is minus. Okay. So incorrect. It is okay. And now one more point. A can tell me A incorrect or C wrongly? Can you imagine? It may be difficult for you. Okay, here might be easy. What is the length of S? Here and here, right? So F must be equal to how many? What is written from here? Here is 2, right? Here is 2, right? So here also regular, so that is here is square root 2, right? So where is it? Yeah. A must be positive, right? So square root of 2. And
Minus 3.
the distance from here to here float with S. Here is distance here is the 2 distance of here is 2 square root of 2. And here also square root of 2 plus so that's the 3 square root of 2. Right? Equal that. So let's try about that. Okay, not because it makes it. Let's try to multiply. If you have double become what? A in original A 2 0. 2 0, right? 2 0. 2 0 and 1. Right? Remember this. And then dot over here is take dot over here you can see here is square root of 2 square root of 2 0 and here is
Just square root of 2.
square root of 2. Right. And here? And here what are you? Minus square root of 2. And 0. And here minus 2 square root of 2.
Minus 3 2.
3 square root of 2. And here is 2. 1. Is it okay? And can you verify with your geometry? Incorrect, right? And similar, B also the similar, you can see to check this. So do you know how to translate between the system? Only two systems. Is it okay? A little bit mathematical, right? So back to here, you can see the idea. They think that here it translates. Okay, then they define the vector from here to here. Okay, but actually I think the next translates rotation. He also translates and rotates. Translate with and rotate with. Translate, rotate, you can see. The idea also is similar here, translate and rotate. Right? And now we are 2D, so rotation is quite simple for you to see. In 3D also, you also had a rotation, but you also know about one formula about to determine the how to rotate in 3D, right? But actually then you think about translation and also rotation. So back to here you can see. So you can see that it's similar to here. It's similar to here. So you multiply to here, you divide here, right? So here. What are you doing? So that will go to, I think the order here is missing about it. Here is C, not zero C. Because zero C is not the homo, not the 4 dimension, but now here only 3 by 3. Here is, but the horizontal 3, 0, and here is similar to this. Similar. But now it's 2D, but here 3D, it's similar. So 0 here represents for 0 here. Horizontal. 1 and 1 here only. And here, remember, here actually dot product. This is dot. So you can see, in our way, you can see that is a fraction without the reverse vector. So that's why in this case, I only go. So that's why I go from this to this. Can see? In my notation here, I use D come from here to here. In theory, that here if vector C come from 0 to here, but you have to take the minus, so that's why you see. Okay? So that's why. Okay, all of the theory here is similar to here. You have to translate the camera to the world. And then all of the term we will also transformation by that way. All of the, if you want to determine the coordinate of A, B, C, whatever in world, you also multiply by this. That is it. Okay? You compare 2D and 3D. And actually in 3D you have to think about more difficult. Let's think that for me. They are missing about here, I think. No, right? No 3D. Again here in 4, because in 3D so without the vector is 4 dimensions, so that's why here the matrix here is 3 by 3. In your case, 2 by 2 because it's 2 dimensions. 0 without the horizontal vector. And 1, that is very 1. And here is, remember, the actually the same as our here. Rotation transform of vector, but I know. Very clear? Okay, now I need. So you can summarize. Okay? This equation help you to transform from world to camera. Okay, or multiple. Maybe here, right? Okay. And from camera to image, you only have video, right? Video. So I system right here. From camera to image, you have this expression in video, not slide. So you can see you combine two of them together. Okay, so you combine two of them, you can see like this. Here, the different. Remember here similar. Here you don't have see here. You don't have that. Here from S word, some sample here, you transform by this matrix, it come to camera. But right now you have to transform back next to the image plane. So from here to here for image plane. From here. Okay. Let's see. So if you learn computer office, then this matrix we call this matrix we call what? Model view matrix. If related, we call external parameter or we call extrinsic. Extrinsic or external. Means that it not categorize on, it not specify the internal parameter of camera. Here, just related outside without the rotation and translation only. So we call model view matrix in computer graphics. Yeah. And here we call projection matrix. And here at intrinsic camera, in computer graphics we don't have it. We don't have it. Because the computer graphics is just generate picture. No need to specify the camera, okay? Okay, so that's why here computer graphics for me. Here projection. So when we go now in computer graphics, model view matrix here. Okay? And projection matrix here, right? And here after that, I don't have, but the hand are not order because no polar matrix. But right now you have intrinsic, that is camera. It tells you about the focal plane, also the center of image, also the skew image, also the skew of visual. Okay, that is very important somewhere. So again, for internal parameter, that is intrinsic, okay, 3 by 3. Actually only 1, 2, 3, 4, 5 only. But you can see usually they have this color. Usually 5. In general, they also model 5, 1, 2, 3, 4, 5 skew. What is skew? Because on the river they assume the pixel in square. Okay? Square. So that's why you can see before that you have F because it's the same. But if you use different volume in that, you assume the visual might be rectangle. Might be different. But not so difficult, not so different. Usually if that is rectangle, what that is this side nearly the same. But if you have like this, if not, you model the visual, not the rectangle, but that is that's it. What I mean? I said we call the parallel log point. In the we call it. So you can see in computer graphics, in computer vision, okay, you specify 5 value in that, what do you mean? You have the picture. You are seeing that the sensor inside of the camera sensor, right? Sensor without the image plane. That is now the electric device. The shape of visual right now here may be general, right? So S represents for skew, that is related to the angle. Alpha S and Y related to here S, here Y related to the side of this on the side of this. And PF you want without where is the center of picture. So So that we, so after calibration match, and you have to determine on or off function here. Intrinsic also extrinsic calibration. Okay. So okay, I tell you about a long, just some minutes. Very important. Look at the ball. In remember the form of interest. Usually, unfired equal to probability F, right, divided by sine of pixel on F, and F divided by sine of pixel on Y. Sine of pixel not this. That's related to the angle here. PS we are in the center. Okay, that's why you have to, now you have a camera model on it. Here. Okay, in order to compute or determine the location of pixel corresponding to S, Y, Z, you just multiply on right side both of them. And remember here, just matrix, right? Matrix, remember, right? You just multiply. Then until here you get where I see in the tree. Is it okay? That is. So here we found the camera model. Camera model. And now you have to calibrate, or we call calibration as I told you before. That is calibration is process. Again, very simple. You have physical camera. Physical means you told it. But you can see in mathematics, they have that in model. Okay, and how to know the value of that, and then when you know value of that, and if not, you can generate picture. Okay, you can generate picture. For example, you can see here, as we I had a picture like that. Here I work in one process of 3D reconstruction. Okay, and actually I had a model. And then I calibrate the camera, and then I know the camera model, and then here the picture I generate from the camera in computer office, but use the same parameter of the physical camera. This is what I mean. And okay, now we talk about calibration. Okay, you can see what I mean calibration. First, in order to perform calibration, you have to prepare the image. Very well now you use the calibration chipboard. Maybe I have a picture of it. Let us see where. Maybe here. In order to determine the on or parameter of the camera, first in drawing you must prepare a chipboard. Okay, or chipboard. you have to design by some software. For example, before when I 10 years ago when I studied about 3D construction more than 10 years, I prepared by using CorelDRAW to design the chipboard. Why I use CorelDRAW? Because when I'm printing, I must know exactly this. It must be accurate. How long for each side of the must be exactly, because we must know exactly the 3D location. That's why we have to prepare chipboard. Okay. After you prepare chipboard, why chipboard? Because we easy to use the hot transform to the deadline. Okay? We learn hot line. When you have the vertical and horizontal, we easy automatically to detect on or intersection. Okay, that is why we have to be flexible. After you get the ball, you have to do like that. Okay, here is just hot transform. Okay, inside. You have to see the deep figure. We are seeing now the jet ball lying on the bottom without adjust at the ejected put 0. We are seeing now. And you can see, you know it, that 0, you know where is it, because you know the shell or how the distance of each shell, so that's why you know S1. It means that you know 3D location. Okay, after you print in the chipboard, can see. So you can see after you have the Y, the Z. So the chipboard around here. You place chipboard on the bottom. Equal to Z equal to 0. Z equal to 0. So that's why you only know because you know the shell of each shell. So that's why you know the look like the on of the report where is it. Okay, you know. Mean that 3D location. X, Y, Z. Okay, that you know, right? Okay. And now, as you study the ball on the bottom floor, I use the camera to capture it. Capture, right? And you capture for example, you have a minute, or we have an image. So that is M material. After calibration in the raw, it can restore the here. And the attrition without the rotation and translation. And also intrusion. So that's why by rotation and translation, it knows where is the camera. And also it also knows the intrinsic camera. And all of them here use the same camera, right? So that's why intrinsic share the same. Okay, but only different on intrinsic without the location of camera. Here after location, after the calibration, you can view like that. It knows exactly where you on 3D where you play the camera. Okay, without the matrix R and T, review of R and T. Okay, and also inside here for what? Also here for matrix 3x3 of the for S and for Y, S, PF, PY, right? That is the member triangle. Okay, that is idea. So the question is how you do? So we have the paper, but the paper is quite simple for you. You can see. And now here you have a paper where that is tell you about that edit. And now for deep learning, I think I encourage you to do exercise here, only exercise. 10 years ago more, that it become difficult. But right now we have a tool for learning, so that's why it's easy to learn because it's only optimal this approach. It minimizes what I mean. And this end, mean that what I mean and first, and mean that the number of image. Fun will capture an image. For any image, you have to get the point only the intersection, so we can number of point that is contained. Okay. So actually, n multiplied with n because sum means that the multiply by it means that the total of what? Of grid point in image. And inside here, what I mean n means that the location of in 3D. Here means that in 3D n. And what I mean here that is the checkpoint. Okay, location in checkpoint. Image number I and then the detection point J. Okay, maybe the image là there, you have something. Maybe here, right? Okay. So you have location. You also know that. And R, T, M, R. It means that A means that the intrinsic camera. And T and R means that the vector. Indeed. Let's see. Yeah. A related to matrix here. R related to here and T related to here, right? So that means that it contains all the parameters you want to load. Here that it becomes variable you want to determine. Okay? So that it should look like in network, in data lake or look like the framework on by top of in Kirab, that is the way you want to load. Okay, so that's why. And what they mean this? Here, represent for n hash from here. If not, given n, you multiply with matrix combine from A and T and generate n. Remember, when you have the 3D location, you multiply with matrix, camera matrix, okay, camera defined like this. You get the location in image plane and then you match together. Okay, so that's why it's easy to train it by image. And okay, you define the function. Now, okay, with the Python, I think Python is easy to learn it and then to know the variable A here. Okay, that is the idea of calibration. So, but in order to know that you read the paper is just very short, but okay, but just some information here. So, okay, I think the rest of the line you have to read by yourself, okay? Because the rest of the line here is related to the calibration with format methods. It means that you have to determine the corresponding point because 3D and then also the 2D. And on the question here, I already give you during the lecture in geometric transform. Okay, I will remember here. And if you can resume that, the idea is same. The idea is then you make the corresponding and you make the question like that. You show. But actually that is the now they have to use the program, okay, to do by making the optimization. That's all. Okay, I think that I want to close lecture on camera geometry. As summarize, you have to know exactly the camera model, how many parameters inside. Relation between how, okay, actually how given the 3D location and then how where see on image plane, you know. This multiple which camera, okay. The coverage, remember the exercise on the right? You can do exercise. And this exercise may be in final exam, I think the best way to just ask for you 2D. Because for 3D, for 2D, you easy to know the rotation, okay? But for 3D, you have to in order to align three together, then you have to have two kind of rotation. So it's more. Okay, that's why exam like that because you know that in principle you can generate into the tree. Is it okay? See your language, okay? Because the topic related to the study on what you feel complicated. Why? Because it's with what?
Math.
Right, it. So usually the party conservation research is for the person love mark only. So right now, okay, believe me, maybe the hardest you already today, but might be language, okay, also hardest, but less it related to programming. We did the learn. But before that, we have to master to know the camera first. Very important, right? Read the book for me, man. Not easy to read, to understand.